Hello everyone. So let's wait a couple of minutes just to give people some time to join. Hello Lobna. So yeah, I just want to make sure that my voice is a little bit better this time. I hope it's not clipping like the previous time. In case it is, just let me know and I'll try to fix it. And yeah, I still have the terrible lag. So yeah, I hope you guys bear with me. Okay, so let's just wait for like 1 or 2 more minutes and then dive into things. So I hope everyone is staying at home, staying safe. We're passing through really rough times these days, and it only needs that we do the right thing for us to get over it. So yeah, I hope everyone is doing fine, and I hope we can kill some time learning at least. I really appreciate those of you who gave me feedback on the last session. I hope that their feedback is like whatever comments they had is fixed in this session. I noticed that the code was not visible last time underneath my picture, so I pushed and moved things a little. Hopefully it will be better this time. Just let me know if anything is not clear. Okay, so let's start then. I guess people can join whenever they want. So yeah, today I'll be discussing the second factor of the 12-factor app, and just a quick recap about what I'm doing here. I'm discussing the 12-factor app methodology, which is basically like a checklist of things that you need to take care of and keep in your mind whenever you're developing an app and pushing it to production. This list is just there to make your life easier. It's a set of best practices, recommendations. So it's really up to you to decide whether or not to use them or follow them. And of course, it depends on your needs and your team and everything. So it's not mandatory for you to follow them to the letter. They're just recommendations, as I mentioned, and you can make use of whatever fits your app. So last time I spoke about code base. It was pretty theoretical, in my own opinion, and I guess most of you, if you have already worked before in a software company, you would have came across it. But starting from this factor, things should get more exciting. I'll add a couple of demos to demonstrate how each of the factors work that I'm going to discuss today. So today I'm discussing basically 2 factors. This one here, number 2, is dependencies, and the other one is about dev prod parity. And the reason I group these 2 together is that they're a little bit related, so it's easier to understand them if you compare them together. And this is what I'm trying to do here. Yeah. So dependencies. What I mean by dependencies is that I need to explicitly in my app declare and isolate dependencies. And these are 2 terms that we need to differentiate between. So declare dependencies and also isolate dependencies. So the first terminology I would like to discuss, as I mentioned last session, there are a couple of vocabulary that we need to learn in order to be able to discuss things with each other. So the first vocabulary here is a packaging system. What is a packaging system? So basically a packaging system is just a collection of tools that you can use alongside your app, which automate the process of installing, upgrading, configuring, or even uninstalling and removing dependencies in a consistent manner. And this is a very important like a condition here, consistent manner. And the package manager basically deals with package as zip files or archives. It gets them from somewhere, install them, like have instructions on how to install them on your system and make use of them in your app. And packages have like names and descriptions and versions and stuff like that to make them distinguishable from each other. So back again to the word consistent. The reason why it's better to use tools like a packaging system to manage your app's dependencies, and what I mean by dependency is a set of libraries or functions or code basically that your app relies on that is needed for it to work as expected. So it's something that you have not written yourself. You're using like an external package or library provided by some third-party source or a friend of yours or something, and your code, the code of your app, depends on this dependency, on this external or third-party code. So you need to make sure that this code is available for your app before it starts working. And to do that, you can either do it manually, and it's not like the recommended way apparently, or you can use tools such as packaging systems to manage these dependencies for you. And what I mean by manage is to basically grab them from whatever source they are available on, install them, and configure them to work with your app. And basically packaging systems can provide like the two things that we mentioned in the title here, declaring dependencies and isolating dependencies. And the difference between them is basically that dependency declaration or declaring dependencies is just listing them out. So it's like a file or a list of dependencies and their versions that your app needs, but just being hard-coded in a specific place to be easy to retrieve them later on. So instead of having to go through the different parts of your app to know exactly what third-party dependencies it relies on, you just put these dependencies in a list, a text file maybe, and use this file whenever you need to reinstall the dependencies. And this is what gives the consistency that I spoke about in the previous slide. In that if you have this list, if you know exactly which package or dependency your app uses, which version, where to get it, it's ensured that whenever you need to rerun or reinstall your app or reproduce an app build, you'll be able to do that with just following the steps in this declaration or dependency declaration. So yeah, it should be full and explicit, and what I mean by that is it should give as much details as possible about the dependencies, so their names and versions and where they can be fetched from and whatever extra metadata or details that can be added to this, so as to make sure that installing the dependencies or running this dependency declaration script results in the same builds or the same results every time it's being run, just to ensure that running it on your development environment would bring out the same results if it got run on the production environment. And this basically simplifies the setup for you and for new developers as well. So imagine someone new joining the team, they'll be able to just run this tool, like this dependency declaration, and ensure that or be sure that all of the dependencies that the app needs will be installed and ready to use. So they don't have to worry about running behind these dependencies to get them installed on their machines. So this is what is meant by dependency declaration. The other aspect that is provided by packaging systems is what we call the dependency isolation. And what is meant by that is that, take this example with me, think about it. given that your app depends on some dependency, some package called package ABC, okay? And you've written your app like 2 years ago when package ABC was first introduced, and it had version 1. And since then, you've been using version 1 of this dependency, but in some other app that you started working on recently, you wanted to use the same package or dependency, ABC. And currently, the latest version of this package is version 2. And the difference between version 1 and 2 is huge, depending on the changelog provided by the maintainer of this package. And they're not backward compatible. And what I mean by backward compatible is that they do not provide the same API. They cannot be used in the same way. This is basically what I mean by backward incompatibility between different versions of a package. Which means that if, for example, there's a certain way or a certain function provided by version 1 of the package, this function might not exist anymore in version 2. Which means that if by mistake you use the wrong version of the package with your app, things might not work as expected. So your old app uses version 1, your new app uses version 2. And both of these apps live on your same machines, the same environment, basically, your development environment. How will you be able to run both apps on your machine without having to do dramatic changes? This is basically what dependency isolation does. Dependency isolation provided by packaging systems ensure that when your app runs, it uses the correct versions of the packages that they rely on. And this is ensured by having what I mentioned previously, the declaration of these dependencies. So for a certain app, you know exactly which version is required for a package by this app. And then the packaging system with its dependency isolation makes sure that this version of the package, this exact version of the package is the one being loaded when your app is being run. So this is basically what dependency isolation does. And both of these things, dependency isolation and declaration, most of the time coexist in the same packaging system provided for the programming language you're using. So yeah, as I said, it guarantees that the versions of the app dependencies used by the app will not conflict with different versions, either of the same dependency, either for other apps on your machine or that are installed widely on your system, given that you, for example, use this package on some other place or app on your system. So yeah, again, dependency isolation ensures that the correct version of the package used by your app is the one loaded when the app runs. And dependency declaration is just declaring the explicit versions of the packages used by your app. So as I mentioned, this differs from one programming language to the other. I mean, the same concepts apply about the declaration and isolation, but depending on the language, you might use a different set of tools. So for example, in Go, which is the language I'll be using to demo this during these sessions, there's what is called Go modules. And in this case, in Go, the same tool provides both declaration and isolation. Same thing is for Node.js, they use NPM. For Ruby, they use what we call bundler. And for Python, they have two different tools to do that. Pip is used for declaring the dependencies, and virtual env is used for isolating the dependencies. So let me jump quickly into a demo. So yeah, I'll be working with Go, as I said. You don't have to have any background about Go. I'll be using very basic commands from it, so don't worry about that. And feel free to follow along with me with whatever language of choice that you want to work with. Or if you have already installed Go, let's do this together, okay? So for Go, just creating a new app means creating a new folder, and inside of this folder we can just have a main.go file, and this is like the main file that is being run by Go. And for Go, usually this is the basic structure of a Go app. It includes the first line here, package main, defining that this file here is part of the main executed package of the program. This is basically the file that gets run whenever you run your app, and it has inside of it a function called main. Similar to other languages, this is the first function that the compiler goes to or the execution environment uses to execute your program from. So let's just do a simple hello world program, and in Go that means typing fmt.println and then hello world. Cool. And As you can see here, like my editor automatically added this import statement here, importing this package called fmt or fumt, which has the function called println that is used to allow us to print stuff to the command line. And to be able to run this, I simply just say go run main.go, and we can see it printed out hello world. Okay. So this is just a normal app. We haven't introduced any of the concepts we learned so far, neither isolation or declaration. And to be able to declare dependencies in a Go app, we use, as I mentioned, Go modules. And this has been recently included in the Go command of the Golang. So you don't have to use a different tool, you just use Go. You provided the mod subcommand and then say init. This basically initializes let me do that again. Yeah, so this basically initializes your app. Okay, so it initializes like a new environment or a new isolation of the app when it comes to dependencies. And to initialize a new app, you have to give it like a package name, and usually, like in Go's convention, this is a URL, and let's say, for example, 12 factor. Okay, so I initialized a new app inside of this folder, and if we checked out like the browser on the left, we will see that this new file go.mod file was created, and it simply has just two things now. It says what is the name of this module, where it resides. So if you want to download this module, it should be available over here. You just head over to this website and you should be able to get it. This is just a dummy website for now, but usually this is the place where you explicitly say, as a maintainer of a package, where this package is available. So if I want to download it, I should go to this website, okay? And on this other line here, it states what version of Go was used to create this package. Because as I mentioned, it's not just about packages having different versions, it's also about your programming language itself having different versions. So for example, something that you wrote targeting Go version 1.2 would not work for something you wrote for version 1.3 or 4, for example, okay? So this makes sure that it's explicitly mentioned that this app works perfectly with Go 1.14 in this case. Okay. Okay. So far we haven't introduced any external packages to our program. So for the sake of the demo, let me get this package here. It's called ASCII graph, and it's basically a package that allows us to draw graphs in the terminal. It's nothing specific, it's just something I thought would be cool to demonstrate here. And as you can see here, whenever the program is run, it will display some sort of a graph in the terminal. And so it has some installation instructions here. Let me skip this for now, but it also has this example. So let's copy this example over here and see what happens when I save my file. Okay, so aside from the formatting, nothing major happened. Let me try to run this. And we can see that it has printed out the graph. But here comes a question. So as you can see here, like how Go works, if I need to use an external package, I type its path over here. So I got this one from GitHub. This is the same URL we can see over here. And when I put it here, it gets imported, and then I can use the package which is initialized inside of this variable called ASCII graph. As we can see here, I can just plot some numbers with it. But what we did not notice is how Go was able to fetch this package. And this magically happens now because, as I mentioned, Go modules got integrated into the same Go command. So what happened behind the scenes is that when I said Go run main.go, it checked out the file main.go and checked out if it has any external dependencies that do not exist on my system, downloaded these dependencies, built them, configured them to work with my app, and then built my app using these dependencies. And to make sure that this happened, if we went back to the go.mod file, we will see that this new line was added here, which basically says, in other words, declares that this dependency github.com/whatever/ASCII graph version 0.4.1 has been declared as a dependency for my app, which means that my app will not be able to run without it. Okay, and this means that whenever someone new tries to run my app, they will be able to download the same version, the same exact version of this dependency, and run the app and produce the same results that would work on my machine or any other machine that uses the same dependency declaration file. Okay, so this is the declaration part of the Go modules of Go. Okay, what about isolation? So now I know which package to use. If I use the same package in a different app but with like version 0.3, how do I make sure that the correct version is being used for my app? Again, magically in Go, this is handled automatically. So whenever I say go run main.go, it checks this go.mod file, and it makes sure that the version mentioned in it is the one being used to compile my app. And also, moreover, there is another file that got created, go.sum. And what go.sum has is basically more details about the version of the package that got installed. So for example, it has this checksum here or whatever value here that says, okay, this version of the package is version 0.4.1, and this is like the unique signature for it. So in case something got changed from, like for example, if the maintainer of the package changed something but forgot to change the version, this will let me know here that, okay, something is wrong, you're not using the same version of the package. And this file is used whenever we type go run main.go to make sure that the correct version with the exact like pieces of code inside of it is being used to run my app. So this is basically the difference between declaration and isolation. Okay, Go modules was introduced in like the latest versions of Go. Before that, we used to use like third-party tools to do it. One of which is called Go Vendor. This was like one of my favorite ones. And as you can see, this has been archived, most probably because it got now replaced by the Go modules. So yeah, here it says that. But basically what this used to do is to split the isolation and the like the declaration of the dependencies. You would use it in two different ways: to declare the dependencies and to isolate the dependencies. Okay, but luckily for us Go developers, now this is done easier, in an easier way, by just using the Go command. Yeah. And one other thing that the go mod command does is this download command. Okay, so imagine with me here that you are a new developer joining the team and you want to get started working on the project. You have the declaration file, you want to download whatever packages or dependencies declared inside of it. You can either use go run like go run main.go, and it will do that automatically, or you can explicitly just say go mod download. And you can see it didn't take much time here because already everything is downloaded, but this would make sure that everything is downloaded in your system so that whenever you say go run main.go, it won't have to worry about downloading the packages, and it will just run your program. One other command that is really useful inside of the go mod subcommand here is called vendor. And what this does basically is that it copies whatever dependencies that your app needs inside of this vendor folder here. So inside of it, you can see that it has the code, the actual code for this like ASCII graph package that we're using. So this is like the source code for this package. And this is really useful if you want to run this Go app like on a system running an older version of Go, for example, that does not support this Go modules yet. Or if you, for some reason, do not want to use this Go modules feature of Go. And then the source code will be with you, and you'll be able to reproduce the same results of your app without having to worry of downloading it from a remote source, or the maintainer of this source changing stuff that you didn't get notified about and then messing up your app. You will have the actual source code here, and of course make sure that you follow the licensing in order not to break any rules. But basically having all of the source code needed for your app to run is always the best scenario. The only problem with it is that you will be adding a lot of files to your repo that actually can be reproduced in one way or another by downloading them. But yeah, as I mentioned, depending on your use case, you either like put the stuff in this vendor folder here, and I guess something is similar also in Node.js is Node modules folder. If you have worked with Node.js before, and this ensures that you do not have to worry about fetching your app's dependencies every time you need to run it. Okay, so yeah, this is basically what I have to say about dependencies. So any questions, guys? Is it clear? Okay, if you have any questions, just let me know in the chat, okay? Okay, moving on to the next factor, it's the dev prod parity, okay? And this is basically concerned about trying as much as possible to keep the development, staging, and production on whatever environments you have as similar as possible, okay? And as you might have guessed already, that by having the like dependency declaration and isolation, this helps a lot in making sure that the different environments are yeah, as I said, similar, because we have a script, a declared script of dependencies that we can follow to make sure that the exact packages or third-party code that is being used by our app is there whenever we need to run the app, regardless of when or where we run it. Okay, so that's one thing. One other thing is what we'll discuss in a couple of seconds here. So again, let me quickly define the vocabulary used by this factor here. Parity. What I mean by parity, okay? So since the beginning of time, there have been some gaps between the development and production environments, and this is why we have this factor here to try to solve these gaps. So the three main gaps that we had are the time gap, the personnel gap, and the tools gap. By time gap, I mean that like a developer might be working on a certain feature on his machine, and in case it's like a big feature, it might take him days, weeks, or even months to finish it. And this means that the time difference between what is being served on production and what is actually being developed becomes bigger and bigger with time, which is not something that matches with the other agile concepts, for example, okay? So as I mentioned in the last session, that we need to always update our production environment with the latest code, because this allows our users to give us feedback as soon as possible, okay? So if we have this time gap here, it will be hard for us to do that. And this factor here helps to decrease this time gap, and I'll show you exactly how in a couple of seconds, okay? For the personal gap, so in the old days, it used to be the case where developers would write the code, and then we'd have this DevOps engineers who are responsible for deploying the code, or ops or admins or system admins or whatever they were called at the time, okay? So the developers would be responsible for writing the code, the ops engineers would be responsible for running this code in production, okay? This causes some problems because the knowledge that these two type of personnel have might not be the same, which might cause problems in running the app in the manner expected by the developers. Let's say if there's not like a good documentation or a good README for the app, an ops engineer might not be able to run the app exactly as how the developer imagined it to be run. Okay, so this is the personnel gap. The third gap is what we call the tools gap, which means that a developer working on his machine might be using tools that are different from the ones being used in production. So they might be using like a different operating system, a different kind of database, a different kind of a web server, and so on. So I might be working on a Mac OS on my development machine and deploying to a Linux machine. These are two different operating systems with two different environments and dependencies that we have to worry about. And this creates a gap between the tools. And in a couple of seconds, I'll show you exactly what is the proposed solution by the 12 factor to solve or like decrease these gaps. But first, let's see how we can decrease these gaps, or what does it mean to decrease these gaps. So the 12 factor app is designed, as we mentioned in the last session, for continuous deployment, and it does that to ensure that this gap is decreased as much as possible, okay? So for the time gap, because we have CI and CD pipelines, a developer can make sure that whenever he pushes a new feature to the master branch or to the develop branch, this feature will be deployed in a very short period of time to to like a staging environment or a production environment, and then the developer will be able to check out the results of his code on the actual production or staging environments and fix anything that needs fixing as soon as possible, instead of having to write a huge bunch of code and then deploy it like after a month or so of working on it, and then things become more complicated. Okay, so by having the CI and CD pipelines, we'll be able to lessen the time gap between developing features and deploying these features. As for the personal gaps, there are now tools that I'll be discussing, one of which that allow the developers to be closely involved in the process of deploying their app. Okay, and this allows them to like put out the rules or the steps needed for the code to be deployed, so that if there's some ops engineer or something, he or she will be able to deploy the app in exactly the same way that the developer intended for it to be deployed. Yeah, and also in a couple of seconds I'll show you exactly how this can be done. So basically what we can get out of this is that the developer becomes more involved in the deployment of his app, not just in the development of it. As for the last one, the tools gap, this can be lessened by either using the exact same tools in both development and production environments, but most of the time this is difficult to do, and there are tools that I'll be discussing also in the next slides that help to make both the development and production environments as similar as possible. So yeah, this is basically a table to sum up the differences between them. So for the time gap, it decreases from weeks to hours. For the personal gap, instead of having different people working on it, the same people are now working on it. And for the tools gap, instead of them being divergent, they'll be as similar as possible. And next, I'd like to talk about this tool called Docker, which is a lifesaver when it comes to dev prod parity. So basically, Docker is just like a program that runs on your machine that provide like what we call virtualization, or in this case for Docker, containerization. And what I mean by virtualization is that it provides the ability to emulate a certain environment directly on your local machine. So I can emulate the production environment on my machine, and therefore I'll be able to test out my code on my machine before pushing it to production, and make sure that whenever the time comes for it to run on the production environment, it will run as expected because I've already tested it on a similar environment on my machine. Okay, this is one way to talk about it. Another way is that in case there's a difficulty for me to install a certain tool that is used in production on my machine, because for example, let's say there's a tool that only works on Linux, it does not work on Mac, okay, and then this tool is installed on the production environment. In order for me to be able to use the same tool on my machine, it's either that I switch to a Linux machine, which might not be feasible in all cases, or I use Docker, because Docker can basically create a small operating system that works as an app, just a basic app on my machine, and regardless of whatever operating system I'm using, like if it's Mac or Windows or whatever, Docker ensures that whatever is inside of this like small operating system is running in its normal environment. So if I'm using like a tool called XYZ on production, and this XYZ cannot be installed on my machine, Docker will give me the ability to run this tool on my machine, even though this tool does not support my operating system. And we'll see exactly how now, because like simply it creates a virtual environment, and this is what we call with virtualization or containerization. It contains this tool on my machine in its own private environment that has no idea about where it's being run, and therefore we'll be able to use the same tool on our local machines without having to worry about how to install it or anything. Okay, and this opens a huge world of tools that we can use on our systems. And if we get access to these tools, we can make sure as much as possible that our local development environments are as similar as we can make them to our production environments. Okay, and like the concept that Docker provides is similar to what some of you might know, which is virtual machines. So we know that we can already, if you have done that before, we can run, for example, Windows inside of Linux or Windows inside of Mac using what we call virtual machines, which is like basically an emulation of a whole computer on your machine. But the problem with that is that this consumes a lot of resources from your machine, so it takes a lot of memory, RAM, and disk space. What Docker provide here is a lightweight solution that is similar to virtual machines. So it's more convenient for everyone to run it regardless of the resources available on their systems. Yeah. So how Docker runs or how Docker understands your app is by following instructions in what we call a Docker file. And a Docker file is just a set of instructions that, when run in sequence, will result in, for example, your app displaying some output. Okay, so it has the steps for like defining the dependencies or installing the dependencies of your app and building your app and then running it at the end. So if you want to containerize, and this is the term usually used with Docker, if I want to Dockerize or containerize the app, the demo app that we just built, the one for the ASCII graph, first of all, I need to tell Docker that this app uses Go. So I use this command here called from in the beginning of my Docker file, telling Docker that we need to fetch some base requirements in our containerized environment, and this environment is Go, basically, like the tools provided by the Go programming language. And this Golang, we can see over here, is just a name of like this environment on a website that I can show you right now, which is called Docker Hub. Okay, so if I head over to Docker Hub here and I search for Golang, click over here, I can see that this is where Docker will be able to download the Golang environment from the web to my machine. Okay, so this is the first step. I'm just telling Docker, please download whatever is provided by this image here or repo here, Golang, to my machine, because this is the basis needed for my app to run. Okay, and we can see that a lot of different versions are provided by this repo here, Golang repo, and this allows us to run different versions of Go on our machines. So imagine you want to make sure that your app works on Go 1.14 and 1.13 and I don't know 1.0, for example. You can have all of these versions running on your machine using Docker without having to worry about installing these different versions individually on your machine. And I'll show you, like in a couple of seconds, how we can run different versions of Go on our machines without having to install them, just using Docker. Okay, just remind me in the chat in case I forgot about that. Okay, so yeah, this is the first step in our Docker file here. We just tell it, please fetch whatever environment provided by this Golang image. The next step is just creating a folder where our app will live. So for example, inside of the virtual machine or the containerized machine, we create this folder /go/src/app. And then I tell Docker to copy the go.mod file, which is our dependency declaration file, as well as the go.sum file. Copy them from my machine inside of the Docker machine. Okay, and what I mean by dot here is basically this path over here. Okay, so I'm telling it to copy it from my development machine, my laptop where I'm working, into the containerized environment that Docker is maintaining or creating for our app right now. Okay, so it's just like copying from one machine to the other. And once I copy both of these, I run the command go mod download just to make sure that whatever dependency is defined inside of this go mod and go.sum files is downloaded inside of the Docker image. Cool. And what I mean by Docker image is the environment being created by Docker for my app. So once these commands are run, these three commands here are run, I am sure that all of the dependencies of my app are installed inside of Docker and are ready for my app to use. Next, I'll be running this copy command, which basically tells Docker to copy whatever files are inside of the folder of my app. So basically the code of my app, copy them from my machine to the Docker image or the Docker machine. And then this steps tells Docker exactly how to build my app. So now I'm building it. Just forget about this environment variables over here. I'm just building the Go app into an executable called main. So I'm basically compiling the Go code that I just wrote into an executable, a file that I can just, or a program that I can just run to get the output of my app. And the last step here, I'm telling Docker what is the command it should run for my app to get executed. And in this case, I'm telling it the entry point to this Docker image is to run whatever executable is at this path, which is basically this main executable that we just created. Okay, so let me test this out. I already have, so yeah, to do this, we need to first create this Docker file, and it doesn't have an extension, just Docker file. And let me just copy whatever we have in the slides here to it. Let's hope that copying works. Yeah, cool. So this is the first step. The second step is to create the folder on my Docker image and install the dependencies. Yeah, if you're copying and pasting, make sure that everything is copied correctly, because sometimes it gets messed up from the slides. And the last step here is instructions on how to build my app and run it. Yeah, and I highly advise, if you're doing this for the first time, not to copy it, but just to write it with your own hands so that you practice on writing them out. Okay, so if I save this here, how I tell Docker to now read this file and create the image for my app is to type Docker and then build, and then I pass this flag -t, which is short for tag, which is basically what is the name I want to give for this image. So similar to what we found over here, the name for the Golang image is Golang. I need to give a name to my image as well, so let me call it ramino.me/12factor so that it matches like the same module name we had. And then I tell it where exactly the files of my app lie, which is which is the folder where I'm inside right now. Okay, and when I hit enter, we can see that it starts running through the different steps of the Docker file. So the first step here is fetching the Golang image, and this might take some time if you're running this for the first time, because it needs to download this from the internet to your machine. In my case, it didn't take much time because I already have it. It creates the working directory, it copies the Go mod file, the Go sum file, and then runs Go mod download, and we can see that inside of this, like the downloading of the modules happen, of the packages, sorry. Then it copies the files of my machine, it runs this command to build my app, and at the end it defines the entry point to the Docker file to be this command over here, which is basically used to run my app. Okay, so now the image has been created, and it tells you here that this is the name of your image that was created, and it has given it, like what we see after the name here, after the colon, is the version of this app. So in case you are publishing multiple versions of the app, you can put the version over here, like what we saw in Go. You see, like for example, version 1.14, version 1.13, and so on. And in case you haven't supplied any version, it just adds the default one, which is latest, which means that this is the latest version of your app. Okay, and in order to be able to run this, we can just type Docker run and give it the name of our image. If I hit enter, we can see that it printed out the graph. Okay, so now this is running using version 1.14. Okay, and this is the same version of Go that I have installed on my machine. I can check that by typing Go version, and we can see that it says Go 1.14. So I told you like in a couple of seconds ago, or a couple of minutes ago, that Docker also allows us to run different versions of the same thing on our machine. So in this case, let me try to run version 1.13 of Go, for example, and I can do that by just typing Go run, and then we can see over here that version 1.13 is so which one should I let me use this one here. Okay, so if I tell it Go run this, and then inside of it I want to run the command Go version, I hit enter. First it says that this image is not available for me to download, and for some reason here, I don't know why it's not allowing me to download it, but yeah, I need to check that why it's not allowing me to do it. But basically, when you run this command over here, it should download the image for you, 1.13-alpine, okay, and execute it. So let me maybe try it from the terminal. Let me say docker. I have some problems with VS Code, the terminal instead of VS Code. Sometimes it does not work. So let me try it from here. Golang, and then version 13-alpine, go version. And am I typing something wrong? Oh, okay, I missed the one dot in the beginning. So yeah, if we try this again, zoom in a little bit to make it clear. If I hit enter, it says, so I already have the image installed on my machine, so it says directly that this is version go.13.9. Let's try a different version just as a sanity check. Maybe there's version 1.12. It says it's on my machine. Apparently I have a lot of versions on my machine. Let's try, for example, version, I don't know, we can check the website for the different versions. I guess it shows us all of the different versions that we can get from these tags here. So if we go to let's go a little bit to the back. So yeah, 1.12, maybe a little bit more. Okay, let me just type anything here, maybe version 1.10. And yeah, it tells you that version 1.10 is not available locally. It needs to be downloaded. And we can see here it starts downloading it on your machine so that it's available for you whenever you want to run it in the future. And yeah, my internet speed is not at its best, so this will take a couple of seconds here to finish. Yeah, but basically when this runs, Docker then executes version 1.10 of Go on our machine. And this can allow us actually to test out our app with different versions of Go and make sure that it works for all of them. If this is like a requirement of our app to work on different versions of Go and not just the latest one or like the one we have built the app with. Cool? So yeah, we can see here the app was downloaded and it says over here that yeah, they are now using version 1.10.8 of the Golang. Cool. Okay, so back to our code here. Yeah, we can see again that we created a Docker file with a different instruction on how to fetch the dependencies, how to build, and how to run our app. And then this Docker file got ran by Docker and created an image for us. So if I type Docker images and give it like, will this work right away? Oh, I need to provide the name. It will tell us, yeah, you now have this image created 6 minutes ago, and this image can be run right away to run your app without having to worry about installing dependencies or how to build it. Cool. So you can just share this image with your colleagues, and there are a lot of services online like this Docker Hub here that we can use to share our images, and then the image will run right away. Okay. Okay, so back to the slides. There's one more thing I want to discuss, and then we'll be done with this session. Yeah, a multi-stage Docker file. So far what we saw is what we call a single file Docker file, okay, or single Docker file. There's a second type or another type of writing Docker files which is called multi-stage Docker files. And what this type of Docker files does basically is that it splits the operation or the process of running your app into two parts. The first part is building your app, and the second part is running your app. And what's really cool about that is that in case building your app requires a lot of things to be present to run it, like downloading packages and the external tools and all of that, and this takes a lot of space, you can split this from the process of running your app, which might not need all of these resources to be present. And this can be done here by telling Docker that this stage here, where we get the Golang, is defined as the builder stage, as we can see over here. And it describes the steps needed. So you can see here it's the same steps needed to build our app all the way until before the entry point part, because we don't want to worry about building that, like running the app here. And the second stage of the Docker file, tell it to start from this other container here called Scratch, and this is just like a shortcut for a very basic and empty operating system that does not consume a lot of space compared to, for example, the operating system needed by, or the environment needed by this Golang image here. It tells it to copy from the builder stage, which was the previous stage, copy the executable file that we built into the root directory of this Scratch image here, and then tell it that the entry point is to just run /main, which is basically this executable file that got copied. Okay, so now we have two stages. The first stage is for building the app, the second stage is for running the app. And the reason why this is really useful is what I'm going to show you right now. So let me add these changes to our Docker file that we already have. Okay, let me actually just create a new Docker file here to keep both examples for you to try out. So let me copy, and then there's no paste here. Let me just do it from the terminal. So let me copy the Docker file to dockerfile.multi, for example. Okay, and inside of this multi file, we need to make some changes. First off, we need to add this builder part over here to tell Docker that this is like the first stage. We need to put this entry point all the way at the end, and then copy this second stage to our file. And yeah, both stages can coexist in the same file. You just need to make sure that you're calling this from command before the beginning of each stage. So here we're using the Golang image, but over here we're using the Scratch image. Okay, and let me get rid of this entry point. Cool. So once we have the new Docker file over here, in order to be able to build it, we just use the same command that we used before to build, but an extra thing that we pass to it is -f and the name of the Docker file we want to use, which is dockerfile.multi. Cool. And when we run it, we can see that now it goes through the second stage as well, getting from scratch, and it tells us at the end that the image was created. Let me do something quickly here. Let me rebuild the images, but with different versions, just to keep both of them, because now the new Docker file, or the image created by the new Docker file, replaced the old one. So let me build the normal, or the single Docker file image here, and then build the second one and call it, for example, multi. So give it a different version here. So now the single one will be tagged with the latest version, and the multi one will be tagged with the multi version here. If I hit enter, we see that it got created. Cool. And what I wanted to show you now is, let me run this command. So docker images, /12 factor, and let me print out. Let's hope I get the command right from the first time. And maybe I can stretch this a bit in case the camera is taking over again, like last time. So basically I'm telling Docker to list all of the images that have the name ramino.me/12 factor, and just print out the tag, which is the name of the image, or the version of the image, and the size of it. And if I hit enter, we can see here that the latest image, or the single Docker file image, takes 372 megabytes on my machine, whilst the multi-image takes only 2.13 megabytes. And this is the beauty of having a multi-stage Docker file, in that it gets rid of all of what is not necessary for our app to run. It just keeps it around until the app is being built, and then it takes the output, or the build result of the first stage, included in the second stage, and this is only what gets distributed out in case we're sharing this with other team members. And just as a sanity check here, let me run the multi-stage app. So this is the latest one. If we don't provide a tag here, or provide latest, this would be the latest one. But if we say multi and run, we can see that it gives out the same results, which means that we had the same output, but now we have a smaller, an extremely smaller image. Cool. So yeah, I guess this wraps up what I have to say for this session. I can wait for a minute or two in case any of you guys have any questions. Okay, so as always, feel free to reach out to me in case you have any questions, if you have any feedback regarding the sessions, or you need to learn more about anything. And as I mentioned before, make sure to practice things with your own hands, just not to forget them, and gain more experience about how to use them. And yeah, looking forward to seeing you guys in the next session. So yeah, until then, good luck and stay safe. Stay safe. Bye.